Alright, so this should be the last video of the week, and you'll be thankful to know that things calm down at this point. But you will need a calculator, and it's nowhere near as bad as before. What we're looking at in D1.6 is application of green chemistry in the chemical industry. Now, they've not been very specific or clear with what types of questions you could get asked. So I'm going to try and cover some of the things that would likely come up to be worth the most amount of marks. We're going to look at something called percentage atom economy, and it is different to our percentage yield. So you can see our percentage yield, we did this right at the start of the course. If you go back a few weeks, you'll find your percentage yield, actual over theory times 100, if you remember that. But I put it there just to remind you that this is not the same thing. Percentage yield tells me about the success of the reaction. So if I did a practical, how much stuff did I actually make? So that's basically it. Did I make the stuff? Percentage atom economy tells me how much of the stuff that I wanted did I make with the stuff that I used. So it's a little bit more precise, and it basically tells me how much waste has been put into this reaction. Is it wasteful? Is there a more efficient way that we can do this? Now, you don't need to explain the theory of the differences between them, but you do need to know how to calculate it. So I've got an example here for you that I'd like you to have a go at step by step, just to make sure that you can get the same result as me. You're going to need a periodic table and a calculator, so you can go and get one now. And I'm assuming you've got one now. So calculating percentage atom economy. We're going to use this equation, and it's likely that they will give you this. However, if they don't, for atom economy, it's what do we want over what did we get? That's it. So it's what did we want over what did we get? And it's a theoretical calculation. It's not like an actual lab practical. So there won't be any real masses here or anything. It's typically going to be done with your MRs. So you're going to have to use a periodic table to determine those things. What you can see here, for an example, is bromomethane is reacted with sodium hydroxide to make methanol. So there's our methanol, there's our bromomethane, sodium bromide. Calculate the percentage atom economy for this reaction. Calculate the MR of the products is step one. So what is the MR of these things? Use your periodic table. What does the product in the question desire? That's the important part. So it says here, calculate the percentage atom economy for this reaction. Bromomethane is reacted with sodium hydroxide to make methanol. Methanol is the desired product. That's why we're doing it, to make methanol, which means this guy, sodium bromide, is a waste product. We don't include this. So substitute into the equation like so, and I've got the answer down here, but let me show you where these numbers are coming from. So you can make a note of this if you'd like. So what we've got is we have, oh, my brain's freezing. Okay, cool. Atom economy. What we need to do is, it's the MR of our desired products divided by the MR of all our products. So we're only interested in the product side. What we are interested in is the methanol. We've got 1 carbon, 3 hydrogens, 1 oxygen, and then another hydrogen. You might also write it like this, C4H0. I don't like it, but I do think it's easier to teach, and I do think you guys find this a bit easier to understand. So C4H0. When I use the periodic table, I'm going to get a value around 32. I'm going to divide this by my overall all products. So that's everything on this side. So that's going to be my 32 plus my sodium bromide, which is 102. I'm just going to call it 103. And then we're going to multiply that by 100. And you can see there's the calculation, and there's the more precise value, the 23.7%. So that's essentially all we need to do for atom economy, and this could be worth maybe 1 to 3 marks depending on the question. What I've got down here for you, some questions. I've got the answers for you as well, so you can have a go at them. You don't need to rearrange for them. You just need to make sure that you're using this equation right here and getting the value of these things right here as well. Make sure that you can prove that the answer is 51.1%. Have a go at these and see how you go. Right. The next example we're going to look for is discussing the difference between low and high atom economy. So later on in the course, we're going to introduce something called addition reactions. So this will be the first time you've encountered this. But basically, when we add reactants together and they make one product, we call that an addition reaction. We're adding everything together. And you can see we're going to have 100% atom economy because we're only making one product. So there is no waste. So addition reactions have 100% atom economy. What I would like you to do is, in this task here, can you prove that to me? Can you show me the desired product over the all products, times it by 100, and show me that final value? Another example we're going to look at is substitution reactions, and these will inevitably have less than 100% atom economy because what we're doing, and we call this a substitution because we're swapping these two things around. You can see that in the final product as well. So we call this a substitution because we're just swapping things. These will have less than 100% atom economy, and what I would like you to do is, can you calculate the atom economy for this example here? I want you to read the question carefully. I've not given you any answers, and I've told you what is going to be the desired product, and you need to make sure that you're using this table to calculate the correct MRs. What I will tell you is that this is methyl bromide. In fact, I'll color code them for you because we don't know nomenclature yet. This is our methyl bromide. This is our sodium hydroxide. This is our methanol. And then finally, the yellow one is our sodium bromide. Have a go at determining the yield for this, and that's it, nice and short. On the very last page, you can see I've got something here for hazards and risks. We're not quite sure how this is going to come up. It's came up previously like this. What I would like you to do is, can you complete this table using the Koch hazard symbols? Some of these are very self-explanatory. You should be absolutely fine. Others, I would search up the term, followed by Koch hazard symbol. Make sure it's the right one you're searching up, and then I would label and identify all of these. Just a quick homework task for you, just to get used to those hazard symbols. And that's it for this week. Well done.